Hi, my name is George Semaganda, and kindly subscribe to my YouTube channel. Today I come still with a continuation to our modeling project of machine learning, that is predicting food security. So our project is agri-sustain, and it's multi-modeling for climatic geointelligence to predict food security. Today I come with a research paper. A research paper is a predictive analytics model for crop sustainability and productivity with tree-based ensemble learning. And this is a paper that gentleman down here, Isaac Coffey, of School of Information Technology, University of Cincinnati of the USA, came up with. And yes, if we take an abstract of why the gentleman came up with this paper, the reasons, the problem statement. Their study aims to use advanced machine learning techniques to predict crop sustainability and productivity, contributing to global food security by 2030. So the research focuses on understanding how environmental factors affect crop growth and developing accurate predictive models. So by analyzing a data set from Cargo, yes, that is a software, the study achieves outstanding performance, indicating the importance of factors like rainfall, potassium levels in crop cultivation decisions, and this research will help farmers make informed decisions and support the zero harm agenda by 2030. So when we look at the literature review of why the modern agriculture technology and the tools it uses, like the GPS tools, the drones, remote sensing, that will help to collect real-time data on weather, soil, and crops. So this data is analyzed using machine learning to optimize planting, fertilization, and harvesting, aiming to increase crop yield, and sustainability. So machine learning finds various applications in agriculture, including predicting crop yields, detecting diseases, recommending crops, managing irrigation, and analyzing soil nutrients. So this focuses on machine learning models in predicting food yield, in predicting crop yield, and providing crop recommendations for agriculture. So if you continue, we should look at the crop yield prediction, the machine learning algorithms, some of the machine learning algorithms that were considered for this paper. We have the LR, we have the k-nearest neighbors, we have random forest, have support vector machine, we have multiple linear regression, we have naive Bayes, artificial neural networks, then convolutional neural networks, recurrent neural networks, and long-term short-term memory. So if we look at for crop recommendations, some of the algorithms that were considered, we have crop selection approach, ensemble techniques for crop yield production, then crop recommendation system based on weather parameters, and then intelligent systems for crop recommendation and yield prediction. So when we continue to the methodology used, they use the study data and pre-processing, then machine learning model selections and training, model evaluation, and experimental setup. So if we continue, we are going to break this down. We should look at the study data and the pre-processing. So here, the data set contains information on soil nutrients and the environment factors affecting crop growth. So with over 2,200 records and 7 predictors, so outliers detections were removed, and 5 outliers here were removed, resulting into the 2,195 clean data points that are being used for this estimation. The min max normalization was applied, and then the data was split into the 80% and 20% training and testing sets, respectively, for the model development and evaluation. So basically, if you look at this, how the mean score was used, and then the mean and the standard deviation of the data point, and down there we are going to see representations, and then how this data is being represented with cargo. So if we continue to the machine learning model selections and training, here 6 machine learning models were selected to be used for this study, and amongst others is random forest, gradient boosting, adder boost, XG boost, light gradient boosting machine, and then the catalogical boost. So why were these ones chosen amongst all the others? So one, they help in handling complex non-linear relationships between features and target variables. Then they manage both continuous and catalogical features without complex processing. Then they provide rankings of feature importance, identifying prominent predictors. Then they reduce overfitting, especially when used with bagging or boosting techniques. So if we continue to the model, still under model selection and training, so basically this is a representation of if you get your study data and then you will process that data. So before you test, you can either test and train, or you can train before you test. So and here, before you feed it to the machine learning model, before you get your evaluation out. So it's an experiment, it's a flow diagram experiment of a machine learning model. Then if we continue, we are going to see the models, the model evaluation and experimental setup. So here they use 3 matrices. So 1 is precision, 2 is recall, that is sensitivity, and then 3 is F1 score. So we are going to see now how how these 3 matrices are being plotted using different models. So if we look at the performance of the 3 matrices, yes, this is a random forest model. So if you look at the score plotted against the crop, there are different crops that we are looking at. So this is how it is visually. This is the output. If you can look at it closely, then we can continue and look at the gradient boost model as well. Still its score against the different crop types. Then we can look at the XG boost model as well. Then we can look at the performance of the LG, the light GMB model. This is how it is, score against crops. Then the adder boost, that is how it looks like. Then the catalogical boost model, and that is how it got out. Remember, we are considering the 3 matrices, that is precision, recall, and F1 score. Then in conclusion, from the findings, the study helped farmers improve their crops using data and machine learning. By adopting to these methods, farmers can grow more food, spend less money, and farm more suitably. So even though the study did well, there is still room to make it better, and that's what we are trying to do right now. We are looking into their study, and now we are finding means on how we can advance and we can have better models around them. So in the future, researchers plan to add more data about things like soil, satellites, try different machine learning methods, then test the study in different places and make adjustments to improve the accuracy. So if we move maybe from locations to different locations, depending on altitudes, weather, seasons, we may find that the models have to be dynamic, and then we shall be looking for a different output or slightly different from these gentlemen's findings. So the team, remember, my name is George Semaganda, and we are working on this project, 3 of us, my colleagues Eddie Kabogoza and Ronald Atuhairi. These are the faces behind the project, and yes, I'm glad we are making this up. And in case you have any questions, please feel free, you can type them out. I'll respond timely. Thank you so much. Again, my name is George Semaganda. Kindly subscribe to my YouTube channel. Thank you.